you guys took the quiz. I'm going to put the answers up here. How many problems was there? Huh? If for some reason, for those of who are not here, you need to come and pick one of these up from me on Monday so you can kind of get an idea. Okay, you guys, so here's the answers. You can check yours. Okay.
What is that very last?
Donut. Hey, how many of you guys put donut on number 15? Okay, so how many put a ring? How many put an inner tube?
Is that like a tuna can?
Okay. No. Yeah, on number 15, if you rotate that, you get that. Now, you guys, this is for you. We're not turning it in for a grade. This is just for you to have a self-assessment, see a little bit what you know. Huh? How many of you guys like it on your grade? It was pretty easy, wasn't it? Okay. Yeah, it was so easy. But I wanted you to make sure you knew that stuff right there. Okay? Any questions? Yes, Grace. What? The test will not be this easy. There will be some questions on the test that will be as easy as these questions, but there will be some harder questions on the test. Okay? So, today, what we're planning on doing, let me just show you really quickly. We are going to review. We're going to, first of all, since I did not, we did that proof the other day on the law of cosines. So, I'm going to be going over that. But, first of all, I'm going to review SOHCAHTOA and the Pythagorean theorem. Then, I'm going to talk about law of sines and cosines. So, we just did that proof of law of cosines, but now I'm going to write them down. I'm going to show you how to use them. Okay, so we'll do that. And this is the most important part. This is a big portion of the test. Okay? We're going to do several examples of solving equations. So I've got 4 examples of that we're going to do. And then this question right here, we'll do this today. This might be as far as we get. But we're going to answer these 3 questions. There's a question like this on the test. So you'll want to know how to do this one. Okay, then find the side lengths. We're going to review 30, 60, 90, 45, 45, 90 degree triangles. We're going to learn a formula for finding the area of a triangle that's different than the formula you know. And this one's useful when you don't have the information you need the other way. So this is just if you're given a certain amount of information, you don't have the other. So this one will help. So we'll use that, find an area. You need to review the volume of a cylinder and a cone. So make sure you have those formulas written down on your 3x5 card. And we did a solid revolution. That donut was an example of a solid revolution. So was the cone, that triangle rotating around, that was a solid revolution on that quiz. And then we need to review about cross sections. Remember, cross section is the slice. If you take a slice, like of this cone right here, if I'm going to tape this together, if you take a slice of a 3-dimensional object, you look at the 2-dimensional slice, so that became a circle, right? And that's the cross section. So those are cross sections. We're going to review that a little bit. Whatever I don't get to today, we'll do the first 20 minutes of class on Tuesday before we take the test. Okay, so everybody got that? I'm also, as you can see, I'm recording this. I will post it to my website, so if there's any part you need to go back and review, this is probably going to be like 45 minutes long by the time we're done today. But if there's just parts you need to review, you can go watch it. If you guys have a friend that's not here, Megan's not here, who's that? And Amy, if someone can let them know. I'm going to send out a Remind 101, but I don't think Megan's on my Remind 101. So someone tell her if you see her on Monday. And and someone if you can tell Amy. Okay, who's going to tell Amy? Someone? Will you tell Amy? Thank you. Megan's new, so I don't know how many of you guys know her very well. Can anybody tell her? Okay, thank you. Okay.
So this is being recorded right now, so later you'll be able to hear my voice on the recording.
Maybe if it's loud enough, I don't know. Yeah, so you can do it. Okay, so this will be recorded and I'll post it on there. Okay, we are going to go back up the top here. We are going to talk about SOHCAHTOA. Didn't I review this in this class the other day?
Yeah.
Do we need to do this again? Let me just review one thing. I want to see how many of you guys can do this problem right here. How many of you can solve? Remember, capital letters are the vertices. Small letters are the sides. And remember, we always put a small letter opposite of its angle. Okay? What if I gave you this equation right here, and I told you B was 22 inches, and C was, let's go 27 inches. And I said, find angle A. Could you do that? I'm going to give you a minute. Find angle A, everybody. So we got 35.43 degrees. Okay, in case you forgot how to do this, from angle A, you guys, we have which two sides? Adjacent hypotenuse. Which, out of sine, cosine, and tangent, which function is that? Cosine. So cosine of A equals adjacent, which is 22, over hypotenuse, which is 27. Well, remember to solve this. To get A by itself, you have to take the what of each side? The cosine inverse, yeah? So if I take the cosine inverse of the left side, it cancels out the cosine, you just get A. But I take the cosine inverse of 22 over 27. So, and you guys came up with 35.43, is that right? Does everybody know how to put an inverse into your calculator? Did everybody check to see if your mode was correct? What mode should you be in? Degree mode. If you are using a scientific calculator that's not my graphing calculator, just make sure you know how to put it in your calculator if it's going to be the same one you're using on the test, because scientific calculators are usually a little bit different than this. Okay? All right. This is the meat of what we're going to do today. The law of sines, cosines. By the way, I set some 3x5 cards out there. Does anybody want one? Okay. If you want one, grab one. Okay, so here's the law of sines. Law of sines goes like this. Side A over the sine of angle A equals side B over the sine of angle B equals C over the sine of angle C. Now, you notice that you see two equal signs up here. You don't need all it's showing is that all those three things are equal. So when you're solving a triangle, and I got to back up. I got to back up here for a second. I'm going to back up. Go back to here. What kind of triangles do you use SOHCAHTOA and the Pythagorean theorem with? Right triangles. Okay? If it's a right triangle, you can use SOHCAHTOA and the Pythagorean theorem to solve them. Okay? What happens if it's not a right triangle? Can I use SOHCAHTOA and the Pythagorean theorem with non-right triangles? No. Okay, that's where the law of sines and cosines comes in. We use law of sines and cosines with non-right triangles called oblique triangles. Spelled like this, O-B-L-I-Q-U-E. Oblique means non-right triangles. So we use law of sines and law of cosines to solve non-right triangles. You might want to write that down. Often when I give the test, this test where we have right triangle trigonometry and we have a law of sines and cosines, I get students that get them mixed up. They forget to determine whether it's a right triangle or a non-right triangle. Okay? You got to differentiate between those two and use the appropriate laws or the appropriate formulas. Okay, now there's two versions of the law of sines. This is one of them. You only need two of these ratios. to solve. Like, let's say I knew side B and angle B, so I'm going to use this one, and let's say I knew angle C. So what I would do is I'd set up a proportion. I'd put the number in for B, the number in for angle B, the number in for C. I mean, no, I wouldn't know that one. That's my unknown. C is my unknown. And then I'd put a number in for angle C, and I would solve for C. I'd have my answer. Okay? So that's how you use it. You just use two of those three ratios. Now, when I'm solving for a side, if it's a side that I don't know, then I put the side length on top. If it's an angle I don't know, you can switch these around. Sine of A over A equal to sine of B over side B equal to sine of angle C over side C. So if it's an angle I'm solving for, I'm going to switch them around. I'm going to turn them over. It'll save you a step when you're solving them. You can use either one of these, but this one, if you're solving for an angle, will save you a step. And this one, if you're solving for a side, it will save you a step. So just keep that in mind. Yeah, well, if that was your unknown, if I knew B and B and the angle C, then I would solve that for C. We'll do some examples here in just a little bit. Okay, this is the law of sines. The law of cosines, remember we did that kind of little proof in class the other day? Remember what it looked like? What did it look like? Kind of almost the start of it looked like the Pythagorean theorem, right? So if I was solving for A, I'd have A squared equals B squared plus C squared. That part of it looks like the Pythagorean theorem. But remember when we were coloring those all in, that you would have, on one side you'd have your two rectangles, and they would be two different colors. But if you did like B squared plus C squared, well, like A squared was equal to like a blue and a red. And if you took the other two squares, and right there you had B squared and C squared, you'd have a blue and a red and a green, or whatever colors they were. But then you had to minus those the two red ones or the two blue ones, whichever they were. You had to minus those, and that, remember, that was represented by BC cosine of A. So you had to minus two of those to get the area. So that was the law of cosines. Now, the law of cosines really is one formula, but it can be written, depending on which one you're solving for, in several different ways. You could write it, if you were solving for B, you would write this one. If you're solving for C, you'd write this one. But I just remember it as one formula. And this is how I remember it. I remember this as if I'm solving for A, so I have the A squared one, it's my other two side lengths I know, right? I square those and add them together. And I minus 2 times those two side lengths, the same two side lengths, times the cosine of the angle that's opposite the side I'm looking for. So I did cosine of A because it's opposite of side A. So right here, let's just see if we can do this one together, you guys. What are my two side lengths I'm going to have right here? A squared plus C squared, right? Because it's just the other two other than B squared, right? Minus 2AC, these two sides again. Minus 2 and then AC times the cosine of what? Which angle do I take the cosine of? B, because this, I'm solving for side B, so it's the angle opposite of the side, so angle B. Okay, see if you can write the third one for C squared. This will help you memorize it a little bit better and know how to utilize it. Okay, let's write it down. That's my two letters are going to go right here. A squared plus B squared. Minus what? 2AB. Times the cosine of what? Angle C, the angle opposite the letter I'm looking for, okay? Those are the law of cosines, but there's really the same formula, all three. It just depends on which.
It's A squared that equals, then you're looking for A.
Yeah, if you're looking for side A, then you'd use this one. If you're looking for side B, this one, side C, this one. But really it comes down to, let's talk about this, and then I'll show you an example, and we'll make more sense. Okay. So, you guys, when is it that we use the law of sines and cosines?
When it's complete.
Oblique triangle. That means a non-right triangle. But how do we know if we use the law of sines or the law of cosines when it's a non-right triangle? And the answer to that is, if you know two angles and a side of a triangle, such as angle, angle, side, or angle, side, angle. If you have that situation, you're going to use the law of sines. Or, one more case, we call this the ambiguous case. If you have two sides and an angle that's not between them, this is called the ambiguous case. I'll talk about that more in just a bit. It's called the ambiguous case. If you have that, then you're going to use the law of sines. And then, what are some other possibilities of information that I have? Three things. But other than angle, side, angle, or angle, angle, side, what's another one? Side, side, side. Angle, 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 except for angles. If you have three angles of a triangle, it doesn't make the same size triangle every time. You can change the size of it because they're proportionally the same. So angle, angle, angle is not one. You couldn't solve for a triangle that you were just given the three angles on. What's another one? Side, angle, side. Those are the two right there. If you're given a side, two sides, and an angle in between them, you would use the law of cosines. Okay, so if you're given a non-right triangle and you're given two angles and a side, you'd use the law of sines. Or two sides and a non-included angle, you'd use the law of sines. If you're given three sides or two sides and an angle in between them, then you would use the law of cosines. And these formulas I definitely have written on your 3x5 card. This is what we're going to be using. Okay? All right, does anybody need me to stay here? Okay.
So you're gonna go with that ambiguous.
Yep. Ambiguous case? Yes. What does ambiguous mean? Who knows? Who's an English person in here? Ambiguous. Kayla, you're a reader. What does ambiguous mean? I always pick on you. That's because I want you to understand, Kayla. Hard to reach? Okay. Vague, maybe? Yeah. Ambiguous, we call it the ambiguous case, because in this case, we don't know for sure. If you're given two sides and an angle, it can actually make two different sizes of triangles. Okay? So, let me just show you really quickly. Give me three lengths.
4.
4, 8, 9?
7, 12, 13.
4, 8, 9. I'm going to go 4, 8, 9. 4, 8, 9. Oh, no, wait, I don't want. You know what? Never mind. Give me. Yeah, I'm just going to draw a picture. I'm going to make it up. Here we go. I'm going to go a 20-degree angle. And I'm going to go a side of 8 and a side of 6. Let me show you. That's a side, and an angle. Does everybody see that? Okay, the angle's not between the two sides. Okay? So if I swing this side down right here till it meets right here, and I form this triangle, that satisfies the requirement of having a side of 6, a side of 8, and an angle of 20 degrees, doesn't it? But if I keep swinging it this way, and it swings back up here, so this side comes down here, and it's still 6, I can even have this triangle right here, which is a different triangle than that one, and it still has a side of 6, a side of 8, and an angle of 20 degrees. So with that information, do you see how I can have two different triangles? There's two possibilities of triangle sizes right there. And so we call this the ambiguous case because we don't know when we're solving one of these which triangle we're solving. We can figure it out after we get them all, but that's what we get. And sometimes we just get one size and we don't know what the other size is. So it makes two different sized triangles. So we call it the ambiguous case. But just so you know, on this test, you're not going to have to worry about the ambiguous case. But when we're all done teaching all 8 modules, and we're going to practice for the test, the SAGE test in the year, I will go over that in more depth, and we'll talk about it then. So don't worry about it now. So we're going to do an example of two angles and a side. And it doesn't really matter what we're given right here. I'm going to give an angle of 23 degrees. And I'm going to give another angle of, I'm going to give a side right here of 16 inches. And I'm going to give another angle right here of, let's say this is 110 degrees right here.
That bottom one's 23.
Okay, yeah. And I'm going to call this A, B, and C. Therefore, what side is this, you guys? Side what? C. What side is this? What side is this? Okay, so we got those. Now, I have an angle, side, angle. Does everybody see that? In consecutive order? Angle, then a side, then an angle. So if you go around a triangle, you have an angle, side, angle, side, angle, side, angle, side. It keeps alternating, right? But the three things I have are angle, side, angle in that order. And I will need to use which one? Law of sines or law of cosines? Sines. There we go. Now, you always want to look for things that are opposites, like an opposite angle and opposite side. Notice I have side C, but not angle C. I have side A. I don't have side A, but I have angle A. I have angle B, but not side B. So I don't have any opposites right here. But could I get some opposites? What could I get? Angle C. What is angle C? 47 degrees? Okay, so this is 47 degrees because the three angles of a triangle add up to 180. So, do you see why if you're given two angles, you can always find the third angle, and therefore you have one side, so you're always going to have a pair of opposites. And so that's why you can use the law of sines with anytime you're given two angles and a side. Okay, because you can always get opposites. Now, this is how I set it up. I'm going to solve for side B first, right here. So, I am going to take B over what in the law of sines? B over what? Sine of B. What's B? Angle B. 110. So B over sine of 110. Which other ratio am I going to take? Or am I going to take the C's or the A's? Why the C's? Because I have both of them. And you always want to take the one you know both of them, right? So 16 is side C. And sine of what? 47 degrees. Okay, now I only have one unknown. Whenever I have one unknown in an equation, I can solve for that unknown, right? What would I do to solve for this unknown? Times both sides by what? Times it by what? Sine of 110. Times both sides by sine of 110. What happens on this side when I times this side by sine of 110? Cancels out. Because I got to address something right here because I keep getting this, keeps popping up in all my classes. If you have a whole number and you're going to times it by a fraction, what do you times the whole number by? The 3, the 4, or both? Let's vote on it. Everybody that says the 3, raise your hand. Everybody says the 4, raise your hand. Everybody says both, raise your hand. How many don't know? If I'm going to times this 2 by 3/4, 2 times 3/4, do I times the 2 by the 3, by the 4, or by both? Okay, everybody that says 3, raise your hand. Everybody that says 4, raise your hand. Everybody that says both, raise your hand. Okay, thank you. You guys got it. It's 3. You guys think of it this way. 2 is a numerator, isn't it? We just don't write 1 under it. And when you multiply fractions, you multiply the 2 top numbers and the 2 bottom numbers together. So 2 times 3, 1 times 4. So when you multiply a whole number by a fraction, you always multiply it by the top number. Got it? Don't forget that because this keeps coming up in all my classes when we start working with law of sines. Okay, so when I times this side by sine of 110, this sine of 110 is on the bottom, this one's on the top. I can divide it into it and get 1. So I end up with B equals. And on the other side, I have 16 times the sine of 110 over sine of 47. Put that in your calculator. Everybody, practice putting that in your calculator right now. I always have students that just sit there and watch, and they don't put it in their calculator, and then they get on the test, and they find out they don't know how. Because of the parenthesis things that come up. So practice right now, putting that in your calculator. Don't forget about where the parentheses go. Branson.
So, why can't we just like do the algebra, solve it? Like the other stuff.
You. Okay? That is a very good question. He's asking, why can't we put an altitude right here and solve it like a normal equation? So, where would I go from here?
You would just, you would get 380 minus 90, 47, find the two top equal 5.
Okay, so we know that this is going to be 90, this is 23, so we can minus 23 from 90 and get that one. Minus 47 from 90 and get that one, so we'd have that angle up there, right? Which we already had that angle anyway, we already knew it was 110. Okay, how would I get side A?
Would you just like, still control on the first one, find the, that.
Yeah.
That one.
Yeah, do you guys see that? I could use SOHCAHTOA on this one to find this length right here, right? And then I could use SOHCAHTOA to take 47 and find A, right? Because this altitude shares a side with both triangles. You can do that, can't you? Yeah, you can do that. But you know what? Law of sines is a little bit faster if you know it.
It's like, yeah.
Okay. But in fact, though, Branson, you can do it that way. In fact, that's how you derive the formula for the law of sines, is doing this very thing right here. And we're going to look at that if we have time at the end of class. If not at the end of class, then we will do it the first of the next class. That's how you derive the formula for law of sines. Now, here's one problem, though. Well, no, it's not one problem. We could find this bottom length and this bottom length and add them together. We did that in the last assignment, didn't we?
Yeah.
So do you guys realize the reason they had to do in that assignment? Just so when you got on these kind of things, you could see that? Branson saw it. So I am. Branson, you made the day. Thank you. Okay. Hey, you guys can use that method. I mean, law of sines is really kind of quick, though, because you don't have to draw on the you only have one calculation to make instead of 3 or 4. See, I would have to make, if I did this altitude thing, I'd have to make this calculation for the altitude, then this one right here for this length, then this one for A, and this one for this length, and then I'd have to add these two together. That's 5 calculations, right? This one, I make one calculation to find A and one calculation to find B. So there's 2 calculations to solve the triangle. Does that make sense? So it just saves a little time. But if you want to do it that way because you understand that way, go for it. That's a good way to do it. Okay, so does everybody put 16 times the sine of 110 over the sine of 47? What'd you get?
6.
Oh, this is B we were solving for, huh?
Probably.
20.5? 20 points, round it 2 decimals. 5'6" inches, right? Don't forget to put units. Okay. What about A? How could I use this to find A? I can do the same thing. A over what? Sine of A. What's A? 23 equals C, which is 16 over sine of 47, right? Okay? Times both sides by sine of 23, so you get A equals 16 times the sine of 23 all over sine of 47. Putting that in your calculator, and now you have A. You have A. This is just a time saver, law of sines is. Makes it a little bit faster and easier. Remember the mountain problem where we had to find the height of the mountain on the last assignment? If we would have had the law of sines, we could have solved that in one step. Instead, we had to do 3 calculations to get it, right? Plus, find all these little angles. So that's the value of the law of sines. It skips all that stuff. It makes it faster. Okay. Any questions right here? Okay, let me show you Let me give you this example. Let's go 18 centimeters here. And let's go 76 degrees here. And let's go let me make sure I've got this so it works. Is that my phone over there? Okay, let's go. I've got to make sure I've got one that will work here, because this is the ambiguous case. They don't always work. Let's go 20 centimeters right here. Yes. This is a review for the test. And, well, this part is new for you. So I'll do a couple examples on Tuesday before we do this again, just to review it again. But this is new for you. So this is getting ready for the test. We're going to do a lot more. You know what? There's not very much on the test that requires you guys to do this stuff right here. But I'm going to have to go over this more in depth because we didn't touch it deep enough. So we'll do that next time. Okay, let's solve this triangle. Let's say this is A, B, and C. So this is A, this is B, and this is C. What does it mean to solve a triangle? Find everything that we don't know. We know 3 things, we got 3 more things to go, right? Okay, so let's find something. What would probably be easy to find right now? Angle B? Yeah, why? Okay, yeah. Always look for if you have 2 things that are opposites. I have angle B and angle A and side A. And then they notice that we have side B, so why not find angle B? That would be our unknown, right? Now, this time though, we're looking for an angle. So which formula am I going to use? If I go back up here. Am I going to use the top ones or the bottom ones? Yeah, the bottom ones, because I want the angle on top since it's it'll just save you guys a step if you use it this way. You don't have to, but it'll save you some steps in solving. Okay? So I'm going to go the sine of B, because that's what I'm solving for, sine of B over side B, which is 18, equals the sine of 76 over 20. And I only have one variable, that's B. So I got to get it by itself. What am I going to do? Times both sides by what? 18. 18 on this side, 18 on this side, they cancel out, and I'm left with sine of B equals 18 times the sine of 76 over 20. Everybody put sine of 76 divided by 20 in your calculator. Tell me what you get. What'd you guys get? 0.87, what? Give it to 4 decimal places. 33? Okay. I know some of you guys probably thought you got the wrong answer because you got 0.87, right? And we're looking for an angle measurement. Why did we get 0.87? Because that's not angle B, that's the sine of angle B, right? You guys, the sine of an angle is always going to be between -1 and +1. Just so you know. So don't think you messed up when you got that far. It's always going to be between -1 and +1. We're going to talk about that in Module 6, more in depth, why that's the case. You'll understand that. But you just need to know right now you're going to get that. So now how do you find angle B? Yeah, the inverse. Sine inverse of what? 0.8733. So put that in your calculator. What do you get? Say that again. 60.84 degrees. Everybody agree with that? By the way, this is one time you carry the decimal out a little bit further. Okay? 60.84. Any questions there?
Why do you do that?
Why do I do that? So why do I do what?
But it's like, it's the angle.
The sine inverse? Because we're looking for the angle. Because I have this equation that says sine of b equals 0.8733. I got to get b by itself. So I got to get rid of the sine. The way you do that is take the inverse sine, right? Remember we talked about inverses at the first year? When you solve equations, you do inverses to solve. So there you go, 0.8733. And that gives you 6.84. Can I find the other angle easily? What is it? Has someone calculated already? Huh? 43.16 degrees. Okay. So I only have one thing left. Side C. What could I do to find side C? Let me ask you guys a question. Could I use the Pythagorean theorem here?
No!
Why not? Thank you, because I always get someone that uses that on the test. So make sure you don't forget, you cannot use the Pythagorean theorem here because this is not a right triangle. So what can I use? I can use the law of sines or cosines, but since we know law of sines is easier, so I just suggest using law of sines. I have angle C and I have A and A, right? So I would just use A and A and use those and figure out C, okay? And you can do it from there. All right, now that's law of sines. Let's use the law of cosines. Let's say I give you this, 104 degrees.
You know what? Wait.
What do we do?
Finish that better. We need to find C.
No, okay, I'll give you a second. Go ahead, find it. Find C.
14.099.
14.099 centimeters, right?
Yes, of course.
Okay, you guys got it? Does everybody agree with that?
I have a question.
Does everybody agree with that?
Oh, yeah, I got
So, how many decimal places should we go for?
Okay, you guys hear that question Haley was asking? Good question. How many decimal places should you go? Let's do this. On the test, round everything to 2 decimal places, except for when you got to take the inverse. Then I would go at least 4 places. The more you go out, the more accurate your answer is going to be. If you forget this right here, round 2 decimal places, probably.
What if we ran
To the side thing, I'll probably do.
The inverse what? Oh, you rounded it to 2 decimal places to the inverse. You're gonna probably be way off. You guys, you need to probably take at least to 4 places to be on. You'll be off by quite a ways. Okay, here we go. Okay, here we go. Guys, let's say I have this angle of 104 degrees. Let's say I have this side right here of 13 inches. And this side right here of 17 inches. And you tell me.
Yeah, we're good.
Are we going to use the law of cosines now?
Yeah, we should.
Why?
Because it's named, two sides of an angle.
Because I have what?
2 sides of an angle.
I have 2 sides and an angle? Well, I had 2 sides and an angle on the last one, and we used the law of sines.
Side angle, side angle.
All right, because I have side, angle, side. Last time I had side, side, angle, right? So if the angle is between the 2 sides, you have to use this. Do you guys know there's no possible way you could use the law of sines on this? Why is that? Do I have any opposites? Do I have an angle and a side that's opposite? Do I know both of them? So there's no way I could use it, right?
It was like side, like side to side.
Yeah. And I told you, but I'm showing you the reason why.
Oh,
Okay, so here I have this. So this is what I'm going to do. Whenever you're given side, angle, side, the first thing you find is the side opposite of the angle you're given. So I'm going to find side C. So remember that formula? C squared equals? I'm going to give you guys a minute. See if you can fill it in. Go. Okay, here we go. You guys, I don't really care which side is B and C. Did you know that? I mean B and A. Because I just know that if I'm looking for C squared using the law of cosines, I just need these other 2 sides. It doesn't matter what order they're in. So it's 17 squared plus 13 squared minus 2 times what? 17 times 13. times the cosine of what? 104. Okay? Now, it's really critical that when you're doing these, well, not in this one. Never mind. All I have to do now is to get c by itself is to do what to both sides? What do I have to do to both sides? Square root it. So guess what? All I do is just type that directly into my calculator. Bam. Did you do that?
I did it all when I started.
Okay, yeah, that's good. So, you guys have to practice. Everybody practice doing this.
20 points.
Yes.
Are you going to get math? Don't you don't take the test?
If you don't do what on the test? This one you would have this one you could use the altitude way. Well, actually, this one you would probably have a hard time using the altitude way.
Okay.
Because you would have to split this angle if you did the altitude here. And since it's an obtuse angle, you would have to extend this side out to get this length right here, and then it wouldn't be a right triangle. So you need to use a lot of cosines here on this one. What's that? I don't know. What'd you guys get for the answer, everybody?
23.77.
Is that what you got? Okay, 23.77. Okay. Did everybody get that? 23.77 what? Hey, this is the most common mistakes on this. Watch. As soon as you hit that square root sign, what does it give you? A parenthesis. So that means you're going to have to close it somewhere, right? Also, when you hit that cosine, what does that give you? So you're supposed to close it at the end. Actually, since they're both on the end, it probably wouldn't matter if you didn't close it here. It wouldn't give you any different answer. But you got to be careful, depending on where it's at, you've got to close them. Otherwise, it's going to take the cosine of all those numbers. So you guys, if you didn't get this answer, I would compare it to someone that got it and see what you did different. Check your minus sign, see if you put a negative in instead. Check all your numbers, make sure you put the right numbers.
I hate it.
Okay, just make sure you didn't make a mistake somewhere there. Make sure you put a plus here, a minus here, and then you're timesing all these, right? Okay. Then, what could I use to find angle A and angle B? I could use the law of sines from here, okay?
Oh, yay.
Probably have to stick with cosine.
You know what? You'd probably get... This would be the ambiguous case, so you might want to stick with the law of sines. Because you're going to be using a side and an angle, and so you got to be careful doing that. So you might want to use the law of cosines again to find the angle. I'm going to show you how to use the law of cosines to find an angle. Let's say I gave you this much information right here. Let's say I give you 18 centimeters, 17 centimeters, and 7 centimeters. I'm going to call this A, B, and C. Therefore, this is B, this is C, and this is A. Okay, so this time I gave you 3 sides of a triangle. And we need to find 2 angles at least, and then we can add those 2 together and subtract from 180 to get the third angle, right? So we're going to have to find an angle right here. What angle could I find right here? Does it matter? It doesn't even matter. Okay? In fact, let me show you how to use law of cosines. I don't even care what angle it is. We're going to go for angle A. Okay? What side is opposite of angle A? So that's the one we put on this side, 17 squared. Equals. What are my other 2 sides? 7 and 18. So 7 squared plus 18 squared. Minus what? Minus what? Times the cosine of what? The cosine of A, because that's the one that's opposite of 17, right? Now, here's where you got to do some algebraic manipulation, and there's common mistake that everybody makes on this one. See if you guys can tell me, if I did this, what's wrong with it. if I just went right here and I went in my calculator, 7 squared plus 18 squared minus 2 times 7 times 18, and I hit enter, what's wrong with that? Who wants to say it? You guys, a bunch of you said something at the same time. What's wrong with that? And then I divided it to both sides. Why is that wrong? Why is that out of order of operation? Because you have that cosine, you got to multiply. What comes first, multiplying this cosine or subtracting right here? Multiplying the cosine. And since I don't know what a is, I can't take the cosine yet. So therefore, I cannot add the 7 squared plus 18 squared, and I can't minus that from 2 times 7 times 18. It's a common error, so don't do that one. So this is what I want you to do. Everybody tell me, put 17 squared in the calculator. What is that? 289? 289. 49. What's 18 squared? 324. What's 2 times 7 times 18? 252. Okay, what's 49 plus 324? Huh? 373? This is where most people end up making that mistake right here. They're tempted to subtract those two. But you can't yet because we got to times this one by a cosine first. So let's start getting things the other side. What would I get to the other side first? Minus 373 from both sides. So everybody minus 373. From 289, what do you get? What? Negative 84 equals negative 252 cosine of A. Then what do I do?
Divide by negative 2.
Divide by negative 252. Those cancel out. What's a negative 84 divided by negative 252? 0 point what? Give me 4 decimal places.
3333.
3333. What? It's 1/3? Oh, okay. Thank you.
And you're just like, wait, just get...
I couldn't tell that that's what you said. Okay, so now what do I have to do to get A?
How do you divide this inverse?
Cosine inverse. So cosine inverse of 1/3, because we're looking for an angle, right? Cosine inverse of 1/3, what is it?
70.53.
70.53 degrees. Thank you. By the way, could I use the law of sines from here? Yeah, I can. Okay?
Can we find them all, please?
Yeah, go ahead. I'm going to give you a minute. Jacoy's got that thing where she's got to complete it or she doesn't feel fulfilled. Hey, I'm going to put this is going to be on the end of the video here. You can see it?
Yeah.
Find the measuring angle ACB. I want you to look at ACB right here, right? I just want you to look for a second. This is not a right triangle.
No.
So you have a couple of different options. You can use right triangle trigonometry or you can use law of sines or cosines on this. But in order to do it, you're going to have to find some lengths of sides, right? This one's pretty easy, CB. I'll find this one, right? I can find that one. But how do I find this length, AC? Okay, someone says take the altitude. Yeah, and use what? Pythagorean theorem. And then I have 3 sides, right? I have this is 2, this is 7, and then whatever this is, it's going to be a little bit more than 7. And I could use the law of cosines to find it. Or I could even, I'd probably use the law of cosines and find it that way. I could use right triangle trigonometry because I know these 2 legs right here, and to find an angle, if I draw the altitude, I can use right triangle trigonometry. That might even be easier. Okay, and you can use the inverse tangent. The tangent inverse of, it's going to be adjacent over hypotenuse, so opposite over adjacent, so 7/2. So it's going to be the tangent inverse of 7/2, and you can get that. So I want you to look at that. How would you get the perimeter? And I'm going to add one thing. How would you find the area? I would suggest you guys going to the end of the video and looking at this. Notice it started at about 47 or 48 minutes on the video, so if you just go all the way, fast forward all the way to the end, you'll see this. And look at this problem and see if you can figure out those 4 questions. Find the perimeter and find the area, okay, of both triangles. See if you can do that. Got it?
Got it.
Okay. And remember, when we get back, we'll study these other things, and then we're going to take a quiz. But I would suggest reviewing 30, 60, 90 triangles, 45, 45, 90 triangles. Write down the volume of a cone, the volume of a cylinder. Okay? So I would write all that down and get it from there. Okay?